Welcome to section 9.13, Systems of Equations in Two Variables. This is day number 2 of doing this. We did substitution, we did graphing, and now we're going to do elimination. And I hope this is kind of an Algebra 1 review. If it's not, that's fine. I'll teach you from the ground up, but you might want to pause the video, send me an email, confirm what you think you understand. One thing I wanted to talk One thing I want to talk to you about here is that adding equations, you can actually add equations. You're allowed to. Check this out. It works because every time you have a true equation, two true equations, you can add them up and get another true equation. 1 plus 2 is equal to 3, 4 plus 5 is equal to 9. And if you added them, you get 1 plus 4 is 5, and 2 plus 5 is 7, and 3 plus 9 is 12. Ding! This is also a true equation. We're going to use that a ton in this next technique, which is called elimination. Sometimes it's called Gauss-Jordan or Gaussian-Jordan elimination, and just because of the name of the guys who kind of developed it, made it real famous. I'm also going to talk about the 3 cases for linear systems, and we'll see it on the second page. Check it out. Now, if I wanted to, I could take what I just explained before about adding equations, and I could do that right here. 5x plus 3y is equal to 7, and 3x plus minus 5y is equal to negative 23. If I add them together, I get 8x and negative 2x and negative 16x. And that actually would be a true statement. It would be just as valid for use as any of the others, but it's not that useful. You can do it, you're allowed to do it algebraically, but it's not helpful. Where this really becomes helpful is if you kind of do some preliminary work beforehand and try and figure out what would I have to multiply these by first so that I get elimination. Check this out. If you were to multiply the top equation by 5, and if you were to multiply the bottom equation by 3, you would get a 15y and a negative 15y here. And then when you add the equations together, you get something that's super helpful because the y's eliminate. They cancel each other out. You get 34x is equal to negative 34x because you've multiplied this by 5 to get this by 5 to get this by 3, this by 3, and then you add them and you get 34x is equal to negative 34. It's super helpful, and so then you can figure out what x is equal to, and that's negative 1. The real trick, the real difficulty is having enough foresight to look at this and say, I'm going to try and eliminate the y terms here. So I guess what I need to do to get them opposites of each other, a positive 15y and a negative 15y, is to multiply the top equation by 5. That would give me the 15y, and the 3 by multiply this by 3 to get the negative 15y here. If you have enough insights to see ahead in enough steps like that, then elimination is going to be, that's the hardest part of elimination. The rest of it is a lot easier. Figuring out the first step, figuring out this times 5 and this times 3 is the hardest part. But then once you have x equals negative 1, then you can use that in one of the original equations. I chose the top one. And you get this, you solve for y, and you get y is equal to 4. And that's the solution. Now, you could have used substitution. You could have used graphing, and you would have gotten the same answer, and that would have been fine, but we're practicing this new technique called elimination. Here, I just want to point out that sometimes they ask crazy stuff like, what is x minus y? And you'd have to take the answer and subtract them. Negative 1/2 minus 1/2 would be negative 1, and that would be if the SATs or ACTs kind of throw you in that direction, then just be prepared to take these answers and manipulate them further. But how do you get the answers in the first place? You could use substitution, and you could even argue. You could make a good point that graphing these kinds of equations might be easier than elimination. Or I think even substitution would be much faster because you don't if you solve for x, it would just be subtracting 7y from both sides. That would be pretty useful to be able to do. But since we're practicing elimination, let me show you what that would look like. I'm going to decide you could eliminate y or x kind of equally here, but I'm just going to choose x. And if I'm going to eliminate them, I need to have a 5x. I have a positive 5x, and I would need a negative 5x. So therefore, I'm going to multiply the bottom equation by negative 5. Multiplying the bottom equation by negative 5, you get this. Negative 5x plus minus 35y is equal to negative 15. Adding the two equations together, which you're allowed to do, the x terms eliminate. You get kind of a 0 right here. And negative 35y plus y is negative 34y, and you get negative 17 over here. Y is equal to 1/2. Y 1/2 is kind of a, I normally say don't fear the fraction, but I will say that in this textbook, the textbook is not so mean to you usually that it will give you answers like negative 63 over 4 or something like that. The fractions that are solutions are kind of nice and simple and not so complex or tricky. Just to give you a heads up. If you get, what I'm really trying to say is if you get an answer like negative 63 over 4, then you should probably double check your work because you're doing something wrong. Y equals 1/2, plug it in here, you get 5x plus 1/2 is equal to negative 2, and then solving for x, you get this. This is the value of x and this is the value of y, and if they ask you what is x minus y, you can subtract them. Here's something from chemistry. This is straight out of This is straight out of chemistry and on the SATs and ACTs. So the ACTs have a science section, and in the SATs they ask you lots of sciencey questions in both reading and math. So here, now that we know how to solve systems of equations, we can do a chemistry using systems of equations. How many liters of a 35% saline solution? And if you remember from chemistry, this is given in terms of mass, like percent solution is going to be mass of, say, salt, because it's saline means salt over volume. Rearranging that just a little bit, you get mass is equal to percent solution times volume. So a 35% saline solution will have, for every 100 liters of saline solution, will have 35 grams, 35 grams of salt. And then 15% saline solution must be added to create a 9 liter of 25% solution. This is incredibly difficult to do because there's not a whole lot of numbers here. It's mostly variables, and the variables that they haven't given you. So you've got to really work on your knowns and unknowns. What is unknown? Well, they're asking me how many liters of this solution and this solution. So the two things I don't know is how many liters of the 35% and how many liters of the 15% am I going to have. So I'm going to call them A and B. As soon as you do this, you're able to move forward. If you don't choose letters from the alphabet, you're not going to be able to move forward and write equations. We have a total volume of equation because we know that when we add them up, we're going to get 9 liters total. So A plus B is equal to 9. A liters plus B liters is equal to 9 liters. And then we also have a total mass equation. We have the amount of mass you get from solution A and the amount of mass you get from solution B is equal to the amount of mass you get total in the final concoction. And using our formula here, we can take the percent solution. I'm going to take these 35% and 15%, 25%, write them as decimals. 0.35 A, 0.35 times A, and then 0.15, this is percent solution, times B, this is the volume, is equal to 0.25 times 9 here. So now I have this equation. This is a total volume equation, and this is a total mass of salt equation. The mass plus mass of A plus mass of B gives you the final mass. From a mathematics point of view, it might be easier to clear the decimal first. So I get 35A plus 15B is equal to 225, especially if you're solving it by hand. And then you can, and then here, I'm going to choose to eliminate B. You could very easily make the case that substitution would be easier, but we're going to practice using elimination. And in the assignment, I'd like you to, even if you can use substitution, I'd like you to please use elimination so that we can practice this new skill. I'm going to multiply this top equation by negative 15 so that I get this, I chose negative 15 so that the b's would eliminate. You get this term and this term are opposites of each other. If you were to add them up, you get 0 down here. So basically 20a plus 0 is equal to 90. Dividing both sides by 20, you get 4.5 liters. A is 4.5 liters, so you can use that information in the original. A 4.5 plus, 4.5 is now A, plus B is equal to 9. I'd like you to figure out what B is. Let's talk about the 3 different possibilities, 3 different cases. Actually, 3 different cases. So you could get something like this. This first case here is what we've pretty much been getting all the time so far. We've been getting exactly one solution, and it looks like this. You write it like this. If you were to graph these two, you get a nice happy little X with a happy little intersection. Yay, that's the answer. It's right here. It's 1, 1. Coming in chapter 9, section 3, we're going to start calling these something different. The vocabulary is going to be consistent and independent. Consistent because it has one or more solution, independent because we had just as many equations as we needed. I'll talk more about that later, but just know it's coming. Here, this is a case, we haven't seen any like this yet. If you try and graph these, you get two lines and there's no intersections anywhere. They have the same slope, different y-intercept, but same slope. And so you're like, well, that method failed me. I can't find any intersections. So I can't find any solutions. Let me try elimination. So I'm going to try and eliminate the x's. Multiply it by -1 to get positive x here and negative x here. And when you add them, you get nothing. And actually, often students they won't even write the 0. They'll be like, well, 3 + 1 is 4, but I don't even know what to write over here. Technically, you can write 0 is equal to 4. And as soon as you do that, you see this as a false statement. There is no solutions yielded, and the mathematics, that's because you can't choose any two numbers, x and y, that when you add them up, you get 3, and then when you add them up, you also get -1. It's just impossible. There's no values of x and y that make it happen. So there are no solutions, and we call that inconsistent. Consistent is one or more solutions, inconsistent is no solutions. But that's for later. We're just going to say no solution for now if you want. Check this out. Let's say you're given something like this. It's a third case of the 3 cases. The third case is here. You can see if you graph them, it's kind of hard to find the one intersection because actually the two lines are like just lying on top of each other. They occupy the same space, all the same points. They get graphed equivalently. There's not just one intersection, there's lots of intersections. Every point here is an intersection, which is kind of weird. It's very different from these two. There's an infinite number of intersections, and so that's how we can know right off the bat that there's an infinite number of solutions. Let's say you were going to try and solve this using elimination. If you were going to do that, that means if I'm going to try and eliminate the x's, then I would conveniently be able to divide this by -2, so that we get a positive x and a negative x, and when you add them, they eliminate, you get 0. But when you add the y's, they also eliminate and get 0. Both the variables drop out, they get nothing over here. 0 is equal to what also happens to be 0 over here. 0 equals 0 is a true statement, and so therefore, if you get something that's always true, no matter your choice of x, you can always find a value of y. Like, you can always find, given any value of x, you can find the value of y that will make both of these statements true. So we're going to call that, many algebra textbooks call that the identity case, but starting in section 3, we're going to call that dependent. Now, often in these kinds of problems, you'll see, like on my quizzes and even on my the ACTs, SATs, you'll see something like, not like what is the solution, but how many solutions are there? Is there one solution? Is there no solutions? Or is there an infinite number of solutions? And so then you'd be able to, like, this would be answer choice A, answer choice B, answer choice C, and you have to pick which one it is, depending on the results of your work. In the system, here's how they might do it on the SATs also. And remember, what they do is they take something you normally know how to do, and they, instead of giving you a number where you'd normally expect a number, they'd give you a constant that you have to figure out what it is. A constant is basically a variable. It's basically a number, except you don't know what it is. Like 3 is not changing. We're not graphing m or n. We're graphing x and y, and those are values that are changing all the time. But m and n are numbers that we just don't know what they are, which is kind of I know it sounds like it's a variable, but it's a subtle difference. So they tell you that m and n are constants. They're fixed numbers that are not going to change. And if the system has infinitely many solutions, what is the value of m divided by n? They don't even want to know what m is equal to or n, but they want to know what m divided by n is. Now, infinitely many solutions, by the time you get to the SATs and ACTs or my quiz, I hope that reminds you of this case right here. you've graphed this. You've seen these graphs before, and infinite many solutions means that they've got to have the same slope and the same y-intercept, the same graph. And so if we're going to find what m divided by n is, then we have to be able to compare these two. And I think it might be easiest to take a look at them in y equals mx plus b form, slope-intercept form. So that way I can directly compare the slope and directly compare the y-intercept. This bottom equation is easiest to do. You can solve for y by subtracting 3x from both sides and dividing all the terms on both sides by 4. You get that this bottom equation has a slope of negative 3/4 and a y-intercept of 3/4. Great. Here, let's do the same thing, and it might be a bit more difficult to do because you just see these letters here instead of number. Like, it's a lot easier to think about dividing both sides by 4 than it is to divide both sides by n. But technically, you can do both. We're going to solve for y, and you get, so by subtracting mx from both sides and then dividing all the terms on both sides by n, and finally you get it into slope-intercept form. So therefore you can say that both slopes, you know what both slopes are, and you can set them equal to each other. You know what both y-intercepts are, and you can set them equal to each other. And I think if you were just trying to find out what n is, then this would be easier to solve. But what we're really trying to find is what is m divided by n. And that's, I think, easier over here. Well, here we know what negative m over n is. It's negative 3/4. So if you multiply both sides by negative 1, you get m over n, which is not exactly the slope. It's the negative, like we know the slope is negative 3/4, but we're not looking for the slope. We're looking for what is m divided by n. And then, so therefore your answer is 3/4. Academy Award winner for Best Picture in 1963 was Lawrence of Arabia, probably my number 2 movie out of all time. It's just such an incredible movie. It's really long, actually, but the second half is it kind of drops off. It's not that great, but the first half is so amazing that it's still better than most movies out there. So go check it out. Once you get to the end of the first half, you can go home, you can turn it off, change to something else. But check out Lawrence of Arabia. It's definitely worth it.